Hey guys, Mr. B here, and in this video we're going to be going over the chapter 2.4 notes on chemical reactions. So, this picture here shows a rusty iron chain, which, as most of you probably know, iron, when it's exposed to water or primarily air with oxygen, over time it turns from its typical dark gray silver color to a brown reddish color, and it becomes brittle and flakes off and things like that. So there's clearly a change that has happened, and the material afterwards has completely different properties than the material that it was beforehand. So this is what we call a chemical change or a chemical reaction, and that's what we're going to be talking about in this section of notes. So main thing to understand here in this one is what happens during a chemical reaction or chemical change. What is a chemical property? How's that different from physical properties? And we'll also be talking about reactants and products and the law of conservation of mass. So here we go. What always happens during a chemical change? So the ability for a material to undergo a specific chemical change, what we call a chemical property. Okay. And just to remind you, physical properties were things that you could test that property about an object, and if that object had that property, it would happen, but the material stayed the same before and after. Okay, so in physical properties, there are things that you can test about a material, and after you've done that test, the material still is the exact same material. However, chemical properties are a little bit different, because if you test a chemical property and that material does have that chemical property, afterwards that material is now gone. Okay, it's not there anymore. You've changed it into something else. So chemical properties are a little bit more special in the fact that in order to test them, you actually have to make the material undergo a chemical change and make a new substance afterwards. Okay. So during a chemical change, the material itself is always going to change into something new. So after that change has happened, you do not have the same material anymore. Okay. Physical changes, on the other hand, the material doesn't change into something new. It might look different, but it's still the exact same material. Okay. So just to remind ourselves. So here's a picture of a magnet separating iron from sulfur. This is an example of a physical change. The iron filings and the sulfur powder can be separated out, no problem. And the iron and the sulfur are still the same stuff. We haven't changed them into new material. However, if you were to put these things in a test tube, that test tube would turn red and it would heat up and it might give off a bunch of fumes. And then afterwards, you'd have this black charged stuff left over, and it would not be magnetic. It would not look the same. It would not smell the same. It would behave completely different. This would be an example of a chemical change. Okay. All right. So chemical change is also what we call a chemical reaction. It's just the same word it's a different word for the same thing. Okay. So when one or more substances change into one or more new substances, we call this a chemical reaction. And there are two primary words that we use when we talk about chemical changes and chemical reactions, and that is reactants and products. Okay. Reactants are the materials that you start with, and products are materials that you end with after the reaction has taken place. Now, in this chapter, we're not going to be going in depth on chemical reactions and things like that. That's something we'll learn about in this course way in the future, so in the second half. But for now, those two words should be something that you remember, so that later on when they come up, you at least are like, oh yeah, I remember hearing those words before. I know what a reactant and a product is. So, all right. Now, there are some practice problems in these notes. There's a whole video of me going over those in a separate one. So if you have questions on those or you're confused, go watch that one. But in this one, we're primarily just going to be talking about the information. All right, so what are 4 possible clues that a chemical change has taken place? Sometimes it might be difficult to know if it's a chemical or a physical change, right? So here are some clues that can help you. 1, a transfer of energy. Now, you might be thinking to yourself, what exactly does that mean? So transfer of energy is typically when you're going to have either heat released or absorbed, or light released or absorbed. Okay, so transfer of energy is typically going to be, of course, where energy is moving from one place to another, and usually energy is given off in the form of heat or light. Okay, so something either gives off heat and it gets hot, or it gets cold. Okay, when it gets cold, that means it's pulling heat in, it's absorbing heat. That is a sign typically that there's a chemical reaction taking place. Or if it gives off light, right? It glows a certain color when you light it, or when you light it on fire and it gets really bright, or it gets really dark and it absorbs light. Those are usually indications that a chemical change is taking place. Changing color, this one is, if it starts off brown and then it turns to black, or it starts off green and it turns to red, that's an indication that a chemical change is taking place. Production of a gas. So if you see bubbles form or it fizzes, that's an example of a chemical change that could be taking place. Or the formation of a precipitate. And a precipitate is a solid, a solid that forms from liquids. So a precipitate is when you have two liquids and you pour them together and then a solid forms. And most of the time that solid is not going to be just like a rock, like chunk, like, oh, look at that, there's a solid there. It's usually it will become murky or cloudy. And the solid are these little tiny particles that are floating around in the liquid, but they're very evenly dispersed. So you can't tell that there's a solid there. But if you wait long enough, the solid will settle to the bottom and you'll have a powder at the bottom, okay? So a lot of times when a precipitate forms, you'll start with two clear liquids or that are transparent. You pour them together and it becomes cloudy or foggy looking, okay? It's typically a sign that there's a chemical change taking place and a precipitate is formed. So, okay? And it talks a little bit more here about a precipitate, but again, a precipitate is a solid that settles or forms out of a liquid mixture. One primary example here of that is when you make cheese. So if you take, milk and you curdle it, you get solid chunks of stuff that come out, and then you have liquid, that you can pour off. So obviously milk is a liquid to begin with, but when you curdle it, solid forms, right? That's a precipitate, okay? Now it might seem kind of gross, but I mean, we all love cheese, so don't act like you don't. All right. Last thing we're going to talk about here is conservation of mass. So what does that mean? So some of you guys may have heard of this before, the law of conservation of mass, but basically what it says is that during any chemical reaction, the total mass of the products, which are the things that you end with, will always be equal to the total mass of the reactants, which is the things that you start with, okay? So basically, in other words, matter cannot be created or destroyed in a chemical reaction. You can't make something out of nothing, and you can't just delete, matter out of existence either, okay? So in any physical or chemical reaction, mass is always conserved. And so here's a picture that kind of shows this. So we have two liquids in these little vials, and they're on the scale, and they weigh 43.43 grams. And it looks like they took one of these liquids and they poured it into the other one. And now, one, we see that a color change has happened. Okay, so probably an indication that a chemical reaction took place. Two, this yellow liquid on the right is kind of murky. You can't see through it. Obviously, the clear liquids on the left you can easily see through, but this one on the right, it's hard to see through. So one, color change happened, and two, probably a solid formed or precipitate formed. So very likely that a chemical reaction took place. But either way, we can notice the total mass of everything before the reaction was 43.43 grams, and afterwards, it's still 43.43 grams, okay? So you cannot create matter out of nothing, and you can't just take matter and destroy it. So when chemical reactions take place or physical changes take place, the total matter you start with and end with is always going to be accounted for. Okay, it just might look different, or it might be in a different arrangement, but it's not gone. So, all right, anyway, that is it for this section of notes. Hopefully that helps you. If you had any confusion, though, you can always email me, or we can chat maybe over Google Meet or in class. So again, I'm Mr. Bosquez, and I'll see you guys in the next one. Bye.